Now, also it is very important to know that in this case there is no maximum value, because as you go to the top it goes till infinity. There is no end to the parabola as you proceed upwards. In case of a greater than 0, this goes on, and this goes on and on till infinity. Therefore, there is no maximum value when a is greater than 0. Similarly, in this case, as you go down, and as you go down, it goes till minus infinity. That is, there is no minimum value out here. It goes till infinity. Therefore, in this case, there is no minimum value for a greater than 0, is how we understand equally the minimum value and the maximum value of respectively a less than 0 and a greater than 0. So let's see what is the vertex and axis of symmetry of the quadratic functions. That is, obviously with two different cases. One is a greater than 0 and next a less than 0. As in this case, I have the parabola which is upwards, and here a parabola which is downwards, as we all know here. Now here we know that the coordinates of this minimum point which the graph turns, the maximum or minimum points are called the vertex, the vertices. So for example, here the point we all know is minus b by 2a and 4ac minus b squared by 4a is the minimum value which I have obtained in my previous case. But what do you mean by vertex of a graph is the biggest question. The vertex is the point where the graph turns. Say for example, the graph is going in one direction. Immediately after reaching here, it changes its direction. All of a sudden, it takes a turn to the other side. So exactly the point where the graph turns is called the vertex. So let's see where we identify the vertex of this graph. So let's start approaching from here. As I go here, I go immediately, then I see that after reaching this point, immediately I take a turn. So the point where the graph turns is called vertex. Therefore, here exactly at this point the graph turns, and hence this is the vertex. We all know it is minus b by 2a and then 4ac minus b squared by 4a is the vertex which we obtain. Now in these two cases, I get the coordinates this and this, through which I understand the vertex. So vertex of the parabola with a greater than 0 is this, and the vertex of the parabola with a less than 0 is also this, only with sign of a differing in the first and the second case. Now what do you mean by axis of symmetry? Axis of symmetry is the line along which the two sides of the graphs are symmetric. That is, it acts as the mirror line. That is, when I draw that line along the parabola, exactly I need to get the mirror image. So therefore, let's see where is that line exactly on this parabola through which I get the mirror image or the reflection of one on the other. So symmetrical shape is obtained when I draw a line straight towards this, passing through x equals minus b by 2a. So a vertical line x equal to minus b by 2a which passes through the parabola is called axis of symmetry, is how we understand. So axis of symmetry is x equals minus b by 2a, because this line parallel to y-axis and passing through the parabola will be the line which exactly passes through the middle of the graph, and hence this part is symmetric about this part. It is exactly symmetric about the other side, is how we understand the symmetricity through the line x equals minus b by 2a. So similarly, I identify that if I draw a line x equal to minus b by 2a onto this parabola, also equally I get the graph which is symmetric of this. So this part is exactly symmetric about this. So this also is the axis of symmetry for the given parabolas, respectively for a greater than 0 and a less than 0. So finally, the outcome is a vertex is a point which is a point on the graph where the graph exactly turns. So these two are the vertices, and axis of symmetry is the line where the graph is exactly symmetric on either sides. So here being vertex is this and the axis of symmetry being this for the given parabola. So infinity cases are the most important cases of identifying the quadratic function, never to be neglected with infinite cases. So let's see what happens when x tends to infinity or minus infinity. Where does the function or f of x tend to for x tending to plus or minus infinity? This is what we're going to discuss in the session. So with infinity cases, there are two different cases through which I identify. One is for an upward parabola. If suppose I take upward, of course in this case a is greater than 0, and in this case I take a less than 0. So these are two cases which I have identified. One is a greater than 0 and the other is a less than 0. So in this case, let's see what happens when x tends to infinity or minus infinity. Initially, I start with this. As I see here, x tends to plus infinity implies x is going towards infinity. Let's see what happens to y value. So as I go with the infinite distances, I see that when x reaches here, y reaches here. And when x reaches here, my y equally reaches here. That means I see that when I go more further, it goes here. So as I see that as x is proceeding towards right, y value is going upwards, is what I clearly see with the first three initial points of A, B and C. Therefore, if I imagine or visualize going at infinite distance on x, my corresponding y comes at infinite distance on y-axis. Therefore, when x tends to infinity, obviously in this case y must tend to infinity. That implies y equals f of x tends to plus infinity, as can be clearly seen in the graph. Similarly, let me have x tending to minus infinity. So as I see here with the same case, when I go towards negative side of the function, I clearly see the same case where as I proceed towards left, my y value also increases upwards. But when x tends to minus infinity, y tends to plus infinity, because this is infinity, minus infinity, plus infinity and minus infinity. Therefore, my x tends to minus infinity implies y equals f of x tends to plus infinity, because it is moving upwards but not downwards. Downwards implies minus infinity, upwards implies plus infinity. Therefore, for x tending to plus infinity, f of x tends to plus infinity. When x tends to minus infinity, f of x tends to plus infinity, is how we understand for the graph which is upwards. That is when a is greater than 0. So similarly, let's understand the properties for a less than 0. for each of x tending to plus and minus infinity. Now as I come to the second graph where a is less than 0, the parabola is downwards. Therefore, to start with initial case, x tends to plus infinity implies, that is, when I go towards right, let's see what happens to the graph. When x, let me say, is with one fixed value, then this has the corresponding y value here. Then the other point taken here gives me the corresponding y out here. Similarly, I take the corresponding value here. Therefore, for each of the points A, B, C, I observe that as the points are moving towards right, the corresponding points are moving downwards towards y-axis. That means when x tends to plus infinity, if I move somewhere there till infinity, then this moves down somewhere at minus infinity, because this is plus infinity and minus infinity, and this is plus infinity and this is minus infinity. Therefore, y tends to negative infinity in case of this. Therefore, this implies y equals f of x approaches to negative infinity, is how we understand the property for a downward parabola. Similarly, when I take x tending to minus infinity, that implies y is equal to f of x. As I can see here, when I go towards left, it is going again towards minus infinity. Therefore, for x tending to minus infinity, y is equal to f of x also tends to minus infinity, is how we understand the properties of a greater than 0 and a less than 0 in case of infinity plus or minus infinity. X tends to plus infinity implies x tends to plus or minus infinity implies y tends to plus infinity. X tends to plus or minus infinity implies y tends to minus infinity. Quadratic inequations is the topic for the session. In all these days, we have been discussing about quadratic equations or quadratic functions, where the function was equated to 0 and then factorization and various other properties. Now, in this session, we are going to discuss about quadratic inequations. Now, what is the difference we find between equations and inequations is the biggest question here. So let's reintroduce the quadratic equation and then come back to how we exclusively define the quadratic inequations. So to come with the general quadratic equation, y equals ax squared plus bx plus c. If this is equated to 0, I call this as quadratic equation. Ax squared plus this equal to 0. Of course, with a, b, c belonging to real numbers and a not equal to 0. Now, when this is equated to 0, we call this as quadratic equation. Now, if I remove this equality and replace with greater than or equal to, less than or equal to, I get a quadratic inequation of 4 different cases: greater than or equal to, less than or equal to. So therefore, there are 4 types of quadratic inequations which we identify, one being ax squared plus bx plus c, which is greater than 0, coming to the first case, and ax squared plus bx plus c, which is greater than or equal to 0, coming to the second case, and the third case is this, and the fourth case is this. Are the 4 different cases of quadratic inequations which we identify in mathematics. So these are the 4 types of quadratic inequations which we are going to discuss in the session, and hence the roots of these quadratic inequations are called solution of the given quadratic inequations. Now, there are 2 methods of solving of quadratic inequations. One is the algebraic method and the other is graphical method. So initially, to start with algebraic method of solving of quadratic inequations. So let's take an example problem and see how we can solve the quadratic inequations using the algebraic method. So let's take the example problem x squared minus 10x plus 21, which is less than 0. Now I want to solve this quadratic inequation. Clearly this is an inequality because this is less than case. Therefore, to solve this quadratic inequality using the algebraic method, I initially find the factors. So when I factorize the left hand side of this inequation, I get this to be x minus 3 times of x minus 7, which is less than 0 on factorization using the factors process. Now once I get the factors on the left hand side with inequality on the right with less than 0, let's see how we can use the algebraic method. Now as I see here, since is less than 0, that implies I identify that x squared minus 10x plus 21, the expression x squared minus 10x plus 21 is negative, is how I identify the inequality. The whole inequality, the whole of the left hand side being an algebraic expression which is less than 0 implies the quadratic expression x squared minus 10x plus 21 is negative value being less than 0. Now when this is negative, my coefficient of x squared, which is generally denoted with a, here is 1 because 1 times of x squared, which is 1, is also positive or greater than 0. Therefore, we have previously seen a theorem connecting the algebraic expression ax squared plus bx plus c and a with their signs. So when the expression ax squared plus bx plus c and a are of same sign, then we know that the inequality, then we know that the expression will have its values lying between. So let's recap with the theorem which we have discussed connecting the coefficient of x squared and the algebraic expression. So therefore, as I see from the expression and coefficient of x squared, they are of opposite signs, one being negative and one being positive. Therefore, this implies the expression x squared minus 10x plus 21 and coefficient of x squared, which is 1, are of opposite signs, are of opposite signs. Now when they are of opposite signs, we have the theorem which says that therefore by theorem x lies between the two roots alpha and beta is what we have seen as the proof of the theorem in the previous sessions. For this being of opposite signs, x lies between the roots, and the roots here being 3 and 7 implies my alpha is 3 less than x less than 7 is what is the solution set for the given quadratic inequality. So therefore, as I see that for an expression x squared minus 10x plus 21 less than 0, my solution is all values lying between 3 and 7. That is, I write this in the form of solution set is given by x such that x belonging to real numbers such that 3 less than x less than 7 is what I get as a solution set for the given quadratic inequality. So if I see this on the number line, I clearly identify that if I have minus infinity on the left and plus infinity on the right, then 3 and 7 here, then the values of x which lie between are all the values in the region between 3 and 7 excluding this. So I get this to be the number line. So solution of x is between 3 and 7 but doesn't include 3 and 7, and hence with the open circle is what we understand the solution of the given quadratic inequality. Now let's do the same problem using the graphical method. Now that the algebraic method is one of the method of solving the quadratic inequalities, of course using the previous session of the theorems. Now the second method through which I can solve the quadratic inequations is the graphical method. So as the name itself suggests, graphical method, this method includes the graph of the given quadratic equation or the quadratic function. So let's see how we can solve the problem using the graphical method. To take the same example problem, I have x squared minus 10x plus 21, which is less than 0, which I want to solve using the graphical method. So initially I would like to sketch the function, the left hand side function, which is y equals f of x, that is 10x squared minus 10x plus 21. So this is the quadratic function which I have extracted from the given quadratic inequality. Now I would like to sketch this function. This. Now that we need to sketch the function y equal to x squared minus 10x plus 21, to sketch the graph, there are three basic essentialities which we require. One is the x-intercept, the y-intercepts, and the table of values. As we have already discussed about sketching techniques, initially I would like to find the x-intercepts of the graph. Now we know that x-intercepts are obtained by taking y equal to 0, and y-intercepts are obtained by taking x equal to 0. So initially to find x-intercepts, I take y equal to 0. Is equal to 0 is what I get, and then y being this equal to 0, when I factorize, we have already factorized in the previous session with this being x minus 7 times x minus 3 equals 0, and therefore I get my x-intercepts, which are 3 and 7, using the factors. This makes me understand that the graph cuts x-axis at 3 and 7 is how I understand x-intercepts connected with the graph. So now that the graph cuts or crosses x-axis at 3 and 7, let's see where the graph crosses y-axis equally, that is the y-intercepts. Now to find the y-intercepts, as in the case of this, I equally have my x equals to 0, and therefore when I substitute x equal to 0 in the given function, I get y-intercepts, that is y equals 0 square minus 10 times of 0 plus 21, which is 21. So this is the y-intercept, and these are the x-intercepts, that is the graph crosses y-axis at 21 and the graph crosses x-axis at 3 and 7. Similarly, I have to take the table of values, which I need to take in case of first thing. Randomly take around 4 to 5, with one of them being x and y, and then with different values. One, 2, 3, 4, and 9. So randomly I take values which are away from the roots and in between and outside. So I've taken two values which are away from and one of the value, and then I took the other one through which I got between 1, 4 and away from 7, that is 9. So let's take some random values in the table of values, which I took few values before 3 and few values between 3 and 7 and few values away from 7. So using this, when I have x equal to 1, I have to see what is the value of y. So initially for x equal to 1, my y value is x squared minus 10x plus 21, which on substitution gives me 22 minus 10, which is 12, is what I get when x is 1, y is 12. Similarly, when x equals 2, let's see what is the value of y. So when I have this x equals 2, I have 2 squared minus 10 times of 2 plus 21, which is 21 plus 4, 25 minus 20, which is 5. Therefore, this is 5. When x is 3, we have already proved that y is 0 because it is the x-intercept. So I need not simplify for this. Similarly, when x is 4, my y is 4 squared minus 10 times of 4 plus 21, which gives me 16 minus 40 plus 21. This on simplification gives me 21, 31, 37 minus 40, which is minus 3. Similarly, when x is 9, I get my y as 12. Is how we get the table of values for the different x values as considered. Now we will plot the graph using these table values, x-intercepts and y-intercepts. So let's see how the graph of this can be sketched using the basic x, y-intercepts and the table of values. So let's take x and y coordinates on the real xy coordinate system with this being x-axis, y-axis, and then origin, 3, 4, 5, 6, 8, and 9, which I took on x-axis, and of course minus 1, minus 2, etc. on the left. Then the y values being here 1, but because my y-intercept is 21, I would like to reduce the scale, increase the scale with 1 centimeter as 5 units. Therefore, I get this as 5, 10, 15, 20, 25, 30, etc. So this is what I get as the suitable scale for x and y axis. So in this case, initially I mark the x-intercepts and y-intercepts. My x-intercepts are 3 and 7, that is the graph crosses x-axis at these 2 points, and my y-intercept is 21, implies approximately slightly above 20, that is this. That means the graph crosses y-axis at this point, is how we understand. Now let's plot the other points from the table of values, where my first coordinate, each of the coordinates are given by 1, 12, 2, 5, 3, 0, 4, minus 3, and 9, 12 as taken from the table. So let's mark the first point, which is 1 and 12, which comes approximately here. Now similarly, I plot the second point, which is 2, 5, somewhere out here. And then finally I have 3, 0, which is already plotted on the x-axis, and 4, minus 3, which comes this here. And then I have 9, 12, which comes somewhere here. So I got the set of points which I'm going to join through the smooth continuous free hand. So therefore, as I proceed, I see that my points which I join here are just I get a sort of a shape which is like this, which I can clearly see passing through x-axis and passing through y-axis respectively. Now the equation of this parabola is y equals x square minus 10x plus 21, and this shape of the parabola will decide on what will be the solution of the inequality x square minus 10x plus 21 less than 0. Now as I see that clearly, how we connect this with the inequality is that the whole of the expression which is denoted by y or f of x is less than 0. That means we choose those values of x for which y is negative. Now as I see, my y is positive on the upside of the origin and y is negative down, x is positive and x is negative. Therefore, I search for those values where y is less than 0 or negative. So because this is the region where y is negative, therefore the graph along this region is what will decide the values of x. It is very important that the sign of y will decide on which region the graph requires the respective x values. So y negative in the down region, I see that this is the region where the graph is negative. So this is the region which is required out here where the whole of y is negative. That means for this is the region between x being 3 and 7 for which the y is negative. Any value I take before 3, the y starts coming to the positive side. Any value of x I take on the right takes the y value to the positive side, but any value I take between 3 and 7 takes it down the x-axis, that is, it comes towards the negative side of y-axis. Therefore, for the inequality this being less than 0, my x value should be between 3 and 7. Therefore, I conclude saying that implies x lies between 3 and 7 is how clearly I see in the region. For the region between 3 and 7, the graph is downwards in the negative side of y-axis, but anything before 3 and after 7, it crosses to the positive side of y-axis. But I want the negative, therefore between 3 and 7 is the answer. Is how I understand this graphically.